All right, let's look at your Unit 9 study guide. The first one wants us to find the measure of each arc, and looking at the first arc, it wants us to find CE, which I know right away is a minor arc because it is smaller than 180 degrees. So my answer should be less than 180. I already know that this angle here is 25, and I know this angle here is 90 because I have a 90-degree angle. So all I need to do is add this 25 plus this 90, and that gets me a total of 115 degrees. Okay, number 2, if I look at KHJ, all the way around K to H and then H to J, that's a major arc, so it should be greater than 180, because looking at what I highlighted in pink, that's definitely bigger than half of the circle. So I have 30 degrees here, 72 degrees here, and then I know this half a circle has to be 180. So I'm going to add, because again, I'm trying to find K, H, J. So I can add the 30 degrees, the 180 degrees, and the 72 degrees. When I add all of those up, you should get 282 degrees. Okay, for number 3, we need to use our arc length formula, which I have written up here at the top. So we just need to plug in the stuff that we know and then cross multiply and solve. So the arc length is what we don't know. So this, we're just going to put X. On the bottom, we have 2 pi r. So the only thing we need to fill in there is our radius. And we know our radius is right here from the center to the outside. That is 8. And that's equal to our measure, which is 60 over 360. So we need to simplify our fraction on the right first to make our cross multiplying a lot easier. So we're going to simplify that 60 over 360. So this can be simplified down to 1/6. And your calculator should do that for you if you have a good one. If not, you can always use one of mine. And we have on this side, we can simplify this 2 times 8, and that is 16. So we have 16 pi. Now our last step is we need to cross multiply, so let's start with 6 times x is 6x, and 16 pi times 1 is 16 pi. Okay, on your test, it doesn't say like what to round to or to leave it in terms of pi, so I'm not going to take off points for rounding or leaving it in terms of pi, but for the sake of making it easy, just get the decimal. So we need to get x all by itself over here. So let's divide by 6 on both sides. And then on your calculator, you can just type in 16 pi divided by 6, and it should give you something around 8.38. And again, I'm rounding. If you put 8.4 or 8.377, I'm not going to count off points because it doesn't tell you what to round to. On your test, if it does, make sure you read those rounding questions carefully. And then our label we can't forget is centimeters. Okay, let's do 4. Again, we're finding the arc length, so we're going to use our same formula. And this one's a little different They actually give us the arc length and want us to find the degrees that that angle is. So they want us to find what is this measure? How many degrees is that angle? So we still have our arc length formula. This time we know the arc length. It is 28. So we're going to plug in 28 over, and then on the bottom we have 2 pi r. We know our radius is 9.45. And that's equal to our measure, which we don't know, so we're just going to leave it as x, over 360. So this one, we can do some simplifying, not a whole lot. We can simplify this. We can multiply that. So we've got 28 over, if I do 9.45 times 2, you get 18.9 pi, and that's equal to x over 360. And now we just need to cross multiply. So let's start here. 18.9 pi times x is just 18.9 pi x. And that's equal to, cross multiply on this side, and you've got 28 times 360, and that is 10,080. Okay, now we just need to divide by 18 pi, or 18.9 pi, on both sides because we need to get x all by itself. So if you do 10,080 divided by 18.9 pi, you get, should be, x is equal to, you get 169.76. But anytime you're working with degrees, just round up to the nearest degree. So it would be 170 degrees. Okay, let's jump down to number 5. Now we're finding the area of a shaded region or an area of a sector. And that formula is looks like this. You have area of the sector over the area of the circle, which is pi r squared, equals the measure over 360. So the area of the sector is our unknown, so that's what we're gonna do. That's where we're gonna put our x. Over pi r squared. Now r is your radius. Our radius happens to be 6 feet. And that's equal to our measure, which is 100, over 360. So we can start again by doing some simplifying so that our cross multiplying isn't so big. So let's start with simplifying this side of the equation. So 6 squared, so we've got x over, 6 squared is 36, so we have 36 pi. And then on the right, again, you can type into your calculator 100 over 360, and it should simplify it down to 5 over 18. And then we can cross multiply. So 18 times x is 18x. And then we need to do 36 pi times 5. So 36 times 5 is 180 pi. And then our last step is to get x all by itself, divide by 18. So you're left with x equals 10 pi, or 10 pi as a decimal ends up being 31.4. Okay, number 6, we have a kite. And to find the area of a kite, your formula is 1/2. It's diagonal 1 times diagonal 2. So all we need is the length of our two diagonals. So we have 1/2. Let's find our first diagonal. Our first diagonal is 2 plus 8, which is 10. And our second diagonal is 5 plus this would also be 5. So 5 plus 5 is 10. So then we just need half of 10 times 10 is 100. And half of 100 is 50. And we have meters squared. Area is always meters squared. Okay, next. We've got the area of this polygon. This is a trapezoid. And our trapezoid formula is 1/2 base 1 plus base 2 times the height. So all we need is to identify our two bases and our height. Our bases are the top and the bottom, and then our height is right here in the center. So if we plug those into our formula, we have 1/2, base 1 is 10, base 2 is 14, times the height is 7. 10 plus 14 is 24. And then we can do 24 times 7. We get 168, and then we just need half of that. So our area ends up being 84 centimeters squared. Okay, over here, number 8, we've got a rhombus. And we need to find the area, so we're going to use this formula again, same as our kite. So all we need is our two diagonals. So we have 1/2. Our first diagonal here is 4 plus 4 is 8. And diagonal 2 is 16. That's the whole length there, 16. And then we just need to do 8 times 16, and we get 128. We just need half of that, and we get an area of 64 inches squared. Okay, number 9, they want us to find the volume of this cylinder. So you need your volume of a cylinder formula, which is pi r squared h. So we just need to plug in our radius. Right here's 2. And our height is right here, it's 6.5. And you can type that entire thing into your calculator. You can type in pi, and then you can put 2 squared, and then you can put times 6.5, and you should get 81.68 feet. And now volume is always cubed. All right, we've got a cone. So the volume of a cone formula is 1/3 pi r squared h. So let's plug in. Our radius right here is 3.7. And our height is 8.9. And again, you can type that whole thing into your calculator. You can just be careful when you're typing it in. You've got 1/3 times pi times 3.7 squared times 8.9. And you should get 127.59 inches cubed. So a lot of this unit is just plugging things into your calculator. And if you need help typing things into your calculator, I can help you. Okay, let's go to 11. We've got a sphere. And we need the volume of a sphere. Formula is 4/3 pi r cubed. And we just need to plug in our radius, and our radius is 4. And then type it into your calculator. 4/3 times pi times 4 to the 3rd power. And the decimal should end up being 268.08 feet cubed. All right, then we have a prism. Our prism formula for volume is the area of the base times the height. So let's start with the area of the base. So our big B, our base is 24 by 12. That's the bottom. So 24 times 12. And 24 times 12 is 288. And then we just need to plug that into our B and multiply it by the height. So we end up with 288 times our height is 20. And when you do that, you get 5,760 inches cubed. Okay, 13, a truck whose bed is 8 feet long, 5 feet wide, and 3 feet high is delivering sand for a sand sculpture. How many trips must the truck take or make to deliver 300 cubic feet of sand? So if I'm thinking of a truck bed, it's in the shape of a rectangular prism. You can try your best to sketch this. It doesn't have to be perfect. Just try to sketch a truck bed. And they tell us it's 8 feet long, so an 8-foot long bed. It's 5 feet wide and 3 feet high or tall. So a prism formula is volume equals the area of the base times the height. So the area of the base is 8 by 5. So the area of our base is 8 times 5, which is 40. So I'm plugging this in for my B. And then I just need to multiply that by the height. So I've got 40 times the height is 3. Except I can't write a 3. There we go. So the volume ends up being 40 times 3 is 120 feet cubed. Okay, 14, we have the Pyramid Arena was originally built as a 20,142-seat arena in downtown Memphis on the banks of the Mississippi River. It is 321 feet tall and has base sides of 591 feet. Find the volume of this structure. So if I have a pyramid with a square base, and it's 321 feet tall, and then its base is 591 by 591. I just need to use my volume of a square pyramid formula, which is 1/3 times the area of the base times the height. So we've got 1/3. The area of the base would be 591 times 591, so that's B. And then, let me scoot this over. Our height is 321. So we've got the area of the base here, and then the height here. And then you can type that whole thing in to your calculator. Make sure you don't forget to put 591 twice, so you have the area of your base. And you're gonna get a ridiculously large number. And it should end up being 37,373,067 feet cubed. It's okay to get a number that big. We're talking about a pyramid, so the volume of it should be very large. Okay, 15, the surface area of a sphere is 120 pi. What is the radius? So we have the surface area. We know it's 120 pi. I need to solve for the radius. So I know my surface area formula for a sphere is 4 pi r squared. I know when I find the surface area, it's equal to 120 pi. So now I just need to solve for my radius. So let's start by getting rid of this 4. Divide by 4 on both sides. So you're left with, so 120 divided by 4 is 30 pi equals pi r squared. And now we can divide by pi on both sides, and that will get rid of our pi's. Those will cancel. And then we're left with r squared equals 30. To get rid of a square, we do the square root of both sides, and those will cancel. And the square root of 30 is roughly 5.48. And then we're finding the radius, which is just a length, so we're going to put 5.48 meters. Okay, 16, a roll of paper towels is wrapped around a cardboard cylinder with a diameter of 1.5. The diameter of the whole roll of paper towels is 5 inches. What is the volume of the paper on the roll to the nearest inch? So we have two cylinders here. We have the paper towel roll, and then we have the rod on the inside. So we need to find the volume of the paper towel roll and subtract the volume of the rod so that we take out the middle. So let's just start with the volume of a cylinder is equal to pi r squared h. And then we're going to deal with the big cylinder. And then we're going to deal with the small cylinder. And then we'll subtract. So let's start with the big cylinder. The big cylinder has a radius of, so it gives us a diameter. So the diameter is 5. So the radius is half of that. Half of that would be 2.5. And the height is 11. So if you type that whole thing into your calculator, pi times 2.5 squared times 11, you would end up with, let's just leave this in terms of pi so we don't get a crazy number, 68.75 pi. So I just did 2.5 squared times 11, got 68.75, and then kept my pi. Now the small cylinder has a radius of, so the diameter is 1.5. So half of that, the radius would be 0.75. And the height is again 11. type all that into your calculator, minus the pi, so we can leave it in terms of pi. We've got 6.1875 pi. Now on your calculator, you can type the volume of the big cylinder minus the volume of the small cylinder. So we have 68.75 pi minus 6.1875 pi. And when you do that, you should get the decimal 196.55 inches cubed. Okay, 17, tell whether each solid is a polyhedron. If it is, name the polyhedron. So polyhedron's only characteristics is that it needs to be three-dimensional, it needs to have all straight sides, no curved sides, and it needs to be enclosed. So if I look at A, it's three-dimensional, it's closed, and all the sides are straight. So yes, it is. Now to name a polyhedron, it's either a prism or a pyramid. This is a prism because all of its sides are rectangular. And to be more specific, it's a rectangular prism. For B, again, yes, this is a polyhedron, all the sides are straight. But this time it's a pyramid. And to name the pyramid, we need to look at the shape of the base. The bottom is a triangle. So it is a triangular pyramid. Now C has curved sides, so it's not a polyhedron. And we know the name of this is just a cylinder. Why is my pen? There we go. This is just a cylinder. Okay, last one. Describe the shape formed by the intersection of the plane and the solid. So this is when we did cross sections. So here, if you picture like, it's a sphere, so if you picture a soccer ball, if you were to take a knife, think of this plane as like a knife. If you were to cut a soccer ball in half and open it up, the shape that would still be there is a circle. If you cut it in half and looked at both halves, it would be a circle and a circle. Okay, the next one, if you think about taking an ice cream cone, like a waffle cone, and cutting it in half, that cross section, and you can even see it here highlighted, if they were to cut that would be, that's a triangle. And then C, if you took a box and cut it diagonally, or if you stuck a piece of paper through it diagonally, or if you look at this shape, now we're looking at it at a weird angle, but it's still a rectangle. And that's it.